the second. Then you can name this availability zone A, and this should be availability zone B. Let's just resize it a little bit to make sure you're using our space correctly. Yeah, so we have availability zone A, availability zone B. We have our web, application, and database inside these two availability zones. But now our next question will be the distribution of traffic. How are we going to make sure that the traffic from the end users, it's distributed across this, the web server in these two availability zones? And that's when we look for application load balancer, which will be used to distribute this traffic across the availability zone A and B. That's the EC2 instance inside the availability zone A and B. So let's just look for application load balancer. Nice. We can take this and just put it, just center it here. Make sure it's centered. Make sure we've named it to application load balancer, abbreviated as ALB. And one thing is, remember these, they need to be inside our VPC. So maybe let's just look for VPC also. And let's go with this one. Sorry, Control Z. Then let's do this. Yeah, so that we just inform whoever is going to deploy that we need to have VPC and availability zone. So we just need to make sure it's centered. See, yeah, I think let it remain there. Then we center this, and we just indicate with arrows that this is going to serve availability zone A and B with arrows that way. Nice. Okay, make sure. Okay, see, this is not. We can adjust this nicely like that. We can also adjust this like that. Then let's just try to expand that further so that at least our diagram looks neat. Yeah, so that's the application load balancer, which is going to route track. Sorry, which is going to distribute traffic across the two availability zones, availability zone A and B. Just a moment, let me pick this phone.
As he does this, if you have any questions, I think at the end you can be able to ask them. So do prepare your questions as we go on to the tail end of the session.
Thank you, Mark. Sorry about that. Okay, one thing that we've left out was we need to have a NAT gateway, as I explained previously, that if you want this application, if you want it to access the internet, we need to have a NAT gateway in a public subnet to, the work of a NAT gateway is to translate the private IP address to a public IP address. And the reason why we have a NAT gateway is because we don't want our private IP address to be internet facing, okay? So let's just take a step back, and what you can do is let's just remove this VPC and try to expand our subnet so that it can cater, availability zone, so that it can cater for an additional subnet. So let's just do that quickly. That way, then we can move these two here. And yeah, that way, then we can just duplicate this layer. We can duplicate that and move it here. Nice, and just remove this, that one, that one, that one. And this should be a public one. So there's a different color for public, but let's just name it to public. Same here. Public. Nice. Then we can just look for the NAT gateway icon. NAT gateway. Let's go with okay, gateway. Let's use this icon here. So let's just resize it appropriately and put it inside here. And we can duplicate and have that also inside here. Just make sure everything is centered. Nice. Same here. Nice. And then now we can just name it to show people that this is a NAT gateway. Same here. NAT gateway. Nice. So at least yeah, it's a NAT gateway in a public subnet, and it allows for communication between the private subnets to the internet. That's okay. Then now we can bring back the auto scaling group. Sorry. Can bring back the auto scaling group here. Make sure it's centered. Then we can bring back the VPC. Make sure it's also centered, and maybe just expand this part. Nice. Yeah, now we have the application load balancer, but now for us, you can also have an additional functionality of introducing CloudFront as a CDN, so that yeah, users can benefit from low latency and be able to store their static and dynamic yeah, website. So after the application load balancer will have CloudFront. Let's use that icon. We shape it appropriately. Then we make sure it's centered. Make sure we've indicated it's a CloudFront. Then we have this arrow pointing there. Nice. Then now this CloudFront, it needs to have a firewall that will filter all its traffic to identify malicious activities, and such as maybe the SQL injection and all that. And in AWS we have WAF, the web application firewall. So we can just have our web application firewall to filter all traffic that it's going to get to this CloudFront. So we can just have it here. Then we indicate that it's directing to, let's remove this and try center it this first, 240. And then you can just have this arrow to indicate that it's pointing to CloudWatch. Yeah, and then let's move this a bit down again. Sorry, let's move this down so that don't interfere with our first diagram. Yeah, let it be there. Yeah, so this is we need to name this web application firewall. Then finally we have for DNS we have route 53. So we'll look for route 53 for DNS. There it is. Okay, place it appropriately, and then we can have this arrow. Then we can name this to route 53. Nice. And finally, we have our end users. Now we can just have any icon for users. Then we point directly. Yeah, so and then finally let's have region. We also have an icon for region. Let's use the blue one. Then let's just highlight that. Let's do this. Then we expand it. Then just a moment. Need to expand this to cover all the services so that we just have this restriction that are there inside a particular region. So for this, we need to name the region that we want to host. And for Africa, we can go for, in terms of latency, we'll go for South Africa, Cape Town region because it's the nearest. But in terms of course, we opt to go for another region that was established earlier because services in South Africa tend to be a bit costly compared to other regions. But yeah, let's go with, for this scenario, let's go with Africa Cape Town region. So we can just indicate that it's Africa in brackets, Cape Town region. Nice. Okay, so we have users, and these users, they need to have what we call an URL, which is registered in route 53. And we also, and these users, before they get to our application, all traffic needs to go to the CloudFront, which is being filtered by the web application firewall. And we have an application load balancer that will distribute traffic between the two EC2 instances in availability zone A and availability zone B. Then we have the NAT gateway that is going to translate the private IP addresses to public IP address. That is if you want any communication to the internet. Then we have our 3 tiers. We have the web server, application server, and our database, which is highly available across two availability zones. We have an auto-scaling group spanning across the servers. That's the web servers and application server. And finally, we have AWS managed RDS service, which we have master, and this should be slave. So let's just rename that to slave. So what you can do is send to back. Yeah, we need to make sure that we do everything correctly, because if we make any mistake in our design, it will be a problem to the engineering team. So just make sure that each and every time you key in the correct information to make the work of engineers a bit less hectic. So let's just correct that and return the availability zone back. Yeah, so yeah, that's the master and slave inside the RDS. And yeah, now with that, we have a full architecture diagram that with the services that we are going to deploy to AWS. And now remember, there are other services that need to be present in each and every workload. Services such as Cloud Trail, services such as Cloud Watch for security, guard duty, and all that. So that's something that the engineering team knows, that in each workload, those are the basic configuration that we need to have. So that we don't need to indicate it in our diagram, but in case the engineering team asks for that information, also make sure that you indicate that in our diagram. And what you can do, you can just add here a section of additional services and have the icons for CloudWatch, CloudTrail, Inspector, Guard Duty, and all that according to the customer specification. Yeah, so this is the final design of how it looks like when you try to migrate a monolithic one-tier architecture from your on-prem to a three-tier architecture in AWS, which is highly available, secure, and cost-effective. Now that we've done with the design, I told you there are 3 tools that a solutions architect needs to be aware of. first we've interacted with the first tool, it's the draw.io. But next we need to go ahead and do the costing of all the services that we've drawn here. The services such as NAT Gateway, the web server, which is basically an EC2 instance, the database, which is RDS, and all that needs to be costed. And for that, we have AWS pricing calculator, which is different from let's say it's different from the management console. You don't get the price calculator from the management console. It's a different link that you need to have so that yeah, you can cost all the services. And the thing is that this link is free. You just search for AWS pricing calculator and you'll get one. So let me stop sharing the screen and we get to the AWS pricing calculator, and I just show you an example of maybe how we can cost for the EC2 and the RDS instance. So just a moment, let me stop sharing and I share another screen. But in the meantime, if you got any question, kindly feel free to ask. Just a moment. This is not the right screen I want to share. Stop sharing. Let me share again. Share. Where are we? Here we are. Sure. Nice. Okay, Mark, are you able to see my screen for AWS pricing calculator?
Yes, yes.
Nice. Let me just delete these services that are in here, and we can start afresh. So the first thing is you search for AWS price calculator, you'll get this link. When you get to that interface, this is how it looks like. You can start by editing the workload name. For us, it's AWS User Group, and save. Then if they have maybe different environments such as production, dev, and QA, you can create a group for, let's say, production. But for our case, we have only designed a production environment. So let's name it production. And when we get into that production environment, we can now start adding services. So you click to add service, and let's start. Always make sure that you've chosen the right region, because remember, these services are priced according to the region. So they have different prices, which is a slight variation, but definitely you need to key in the region that the customer has identified that they want their workload to be in. So for us, it's Africa Cape Town region, and the first service that we're looking for is an EC2 instance. We configure that, and remember we have for the EC2 instance we had web server and application server. So in our description we can just name this to be our web server. Nice. Region, it's Africa Cape Town. Then when it comes to tenancy, we go with the shared instance, unless you want maybe a dedicated instance or host, but many people prefer the shared instance. The operating system, we went for Linux, that's okay. The number of instance we are going to go to, because remember we have deployed one in each availability zone, so two there for the minimum amount. Then we go to our EC2 instances, and here there are different instance type. And remember, the specification that we were given originally, it was a one server that had the data, the application, and web server, which was 4 vCPUs of memory. Was it 8 Gs of 4 vCPUs, 8 Gs of memory, and 200 GB of storage. Now, remember that was one server that was serving three different purposes. So for us, we need to break that specifications into the web server, application server, and the database. Now, for our solutions architect, you need to have interacted, you need to be aware of how different workloads operate. For this, it was e-commerce, but you need to be aware of how different workloads operate so that you choose the correct family, the correct CPU, memory, and storage. Now for our workload, we are going to use the T3 family, and let's just key in 2 vCPUs of memory and storage. Let's say, let's go with 4. The reason why I'm going with 2 and 4, remember this customer was also concerned about the cost. And one advantage of cloud is that you can start slow and scale according to how your workload is going to perform. So this is just a basic configuration that you can start with. But as maybe your users keeps growing and all that, you can get back and change the vCPU's memory, or also leverage the use of an auto-scaling group to, span up other EC2 instance to cater for the traffic being experienced. But for now, given that we want cost to be low, we are going with a 4 GB of memory, which basically will be at Medium, with 2 vCPUs, 4 Gs of memory, and $0.0542 per hour. I think that's the cheapest when you compare with the other, so we'll go with that option. Then here we have on demand, and we have these are different payment option. We have compute saving plan, we have EC2 instance saving plans, on demand, spot instances, reserved, and standard and convertible reserved instance. So this we also go according to what the customer wants, but reserved instances are way much they are way cheaper compared to on demand, because there's that discount volume that you benefit from. So we can choose a standard for the EC2 instance. Then finally, these other options, they are optional. You can leave it unless the customer has specified. But now we can get to the EBS and provision. Let's go with 50 GB of memory of our storage rather. Then we can save and view summary. Now, when you look at this, you see that the calculator has given you a monthly cost of the EC2 instance that you're going to experience. Now that is for the web server. So you have to do this for all the that you keyed in the architecture diagram, so that the customer are aware of the monthly cost that they're going to incur if not with this migration to cloud. So let me just add a last service for the RDS, and we can call it a session because of time. So RDS, remember it was Postgres, so we go and configure that. Then for nodes, remember, okay, the region the Africa Cape Town region. For the nodes, we go with one node. But now for the T3.large, because let's say the amount of information that the database is going to be having, it's maybe larger compared to the server. So we go with 2 and 8, the 8 GB of memory for the database. Then okay, the utilization, it's always you can leave it at 100%, but this applies for on demand only. But now remember, the EC2 instance, we went with 1 year standard reserved, no upfront. So for this, we can also do the same and choose reserved instance, 1 year, no upfront. The rest of the information you can leave it as default. For the volume, remember to go with the latest standard. So it's GP3. Let's go with that. Then for storage, let's go with the storage of 100 GB of memory. So those are the main metrics that you can use while designing a cost for the RDS. Then now we can just save and view summary. Now after you've keyed in all the services, you will have a total sum of the monthly cost for the different services, and also you'll have a total of 12 months cost. And so what you can do is you can you can export, you can share this link, you can share it to anyone. So you can generate this link and check cost and see if they are okay with that. Yeah, and then the final tool I talked of documentation, and for us we use AWS Word. I mean, we use Word, sorry, we use Microsoft Word to do the documentation. And basically what is inside the documentation is you need to give the customer, you need to show the customer all the services that you've used. You need to, you've keyed in the diagram that you've drawn in that Word. So that's just exporting the diagram as a picture and inserting it to Word. And also you need to have a section for, let's say, the professional services that the client is going to pay you as you migrate their workload to the cloud. Yeah, so that brings me to the end of my session, and yeah, I'm so glad I've done this. And at this point, I'll request if anyone before I return it to Mark. Yeah. So just allow me to pause and stop sharing so that I can allow room for questions. Thank you so much.
Yeah, thank you very much for the in-depth presentation. So if you have any questions, you can unmute, or you can also raise your hand and I can let you ask. And also you can also use the chat box as we go on. As we wait for that, maybe James, I think you've talked about I've seen your presentation in terms of the use case that you created, the cost calculator that you've done. So what would you say is the importance of planning and documentation before you start, let's say, building anything on cloud? James, can you hear me?
Sorry, I didn't get the last part of your question. Can you repeat?
Oh, sorry. So what's the importance of planning and documentation before you actually build anything on cloud?
Nice. Yeah, that's a great question. Before you do any deployment in cloud, you need to have planned and documented, because one, remember, if you do the implementation incorrectly, you're going to incur extra costs that if maybe it's a customer workload, they won't be liable for that cost. You have to pay for the extra cost that you've done. So I think it's better to do the planning, preparation earlier enough, know the exact metrics that you're going to use in the deployment, so that one, you don't incur losses, two, you don't interfere with the customer workload. Yeah, so that's why it's good to do early planning and preparation. Awesome, awesome. Thank you. Any other questions? Tony.
I have a question, James.
Okay.
First of all, thank for the presentation, very informative on the architecture, where like we have the web server on the private subnet. This means that this web server will use a NAT gateway, and of course, like I assume the like the NAT gateway like will more the web server I assume like is it will cost, I think you have it on private subnet, because NAT gateway like is charged, there is that per hour charges, and then there is also like it's it's charged, and if what would be the reason of having the web server on the private subnet instead of having it on the public subnet where it uses the internet gateway, which is charged and or maybe having to use another solution. This is one question. Then maybe on another question on the step of technical discovery, like and because you have talked about the documentation and stuff before, is it the work of the solution architect to also talk about the IP addressing plan? Because I assume before any implementation, we need to know like to have like that kind of IP planning, or we know if the customer maybe has some reserved CIDR somewhere, and if there is that CIDR is enough for future, like it can be like I don't know the what to use, like expanded or something like that. Those are my questions, but I think I liked the presentation. That is.
Awesome. Thank you so much for that wonderful questions. And okay, the first question, if I got you right, was you tried to ask why we go with a NAT gateway instead of maybe just having the web server directly on a public subnet. As you know,
No,
okay,
no. Let me rephrase my question again.
okay.
I asked the web server in the private subnet. The web server is for serving maybe static content, but if we go with the architecture, what is the reason of having it in private subnet? Because we know that, of course, in the architecting, cost factor is, as you said, is need to be considered, because that means we're having all public traffic going through the NAT gateway, and NAT gateway is very expensive in the sense that if we have is that NAT power charges and also data process is the data transfer charges. But since the web server is supposed to like serve internet traffic, why would it not be put based on that architecture? Why would it not be put in the public subnet where we have the internet traffic going to the through the internet gateway, which is free, and then the application that can stay in the private subnet.
Okay. Sorry. You've been breaking, but from what I've understood, what your question is asking is like okay, there's that aspect of you asking why can't we just have the web server in a public subnet, right? And why are we going with the NAT gateway? Now, to answer you, okay, one thing about the NAT gateway that definitely you know is that it prevents exposing the private IP address to the public internet, right? It's used to provide secure and control internet access to resources in a private subnet. So you're right, we can have this web server sitting directly on a public subnet, but it's kind of an AWS best practice to have the server in a private subnet so that the traffic is being directed to the NAT gateway. The NAT gateway is acting as an interface between the internet and your web server. But to answer you is you can go with that option of having it in a public subnet and excluding the NAT gateway from your architecture. It's 100% possible, and a lot of people use that approach. But for us, majorly that's the way we approach. We come up with the architecture diagram with which have the best practices that AWS do recommend. But when definitely according to the budget of the client, you can exclude that. So yeah, that is on the first question. Then you also ask in terms of IP addressing plan, and yes, that information we also need to know that information prior to the deployment, so that we have the enough information to give out to the cloud engineers to implement. But one thing, if there's information that you're lacking, the cloud engineer can always get back to the pre-sales team so that they can engage to the client to get the necessary information. Does that answer your questions, kindly?
Yeah.
Nice. Thank you for that. Thank you so much, Tony.
I saw there was a question on chat by Kevin. I don't know if you've seen it.
Kevin, let's see.
It was awesome diagram, James. Looking at this, do you feel like a solutions architect? No, sorry. Do you feel as a solutions architect that it's important to have two application load balancers on the web tier and application tier? One being internet facing and the other one internal. Then there is CloudFront that only services static content on a S3 bucket would be necessary. Or you can just read it, maybe let me just post it again on chat, then you can.
Okay, let's see. Kevin, he's asking, okay, it's important to have two application load balancers for web tier and application tier, one being internet facing. I'm betting for the web tier being internet facing, and another one internal for the application tier, the LB is internal. Then since CloudFront only serves static content, then S3 will be necessary. Sorry. Then since CloudFront only serves static content, then S3 will be necessary. Okay, and the WAF being connected to the ALB rather than the CloudFront being connected to the ALB or ALB. So, Kevin, if I may ask, then since CloudFront only serves, or you want us to eliminate CloudFront and go for the S3 and have a WAF being connected to application load balancer that is public facing and have an internal load balancer for the application tier. To answer you, yeah, that's also possible. And yeah, according to the remember the first thing that you need to keep in mind is you need to go with what the customer wants. So yeah, that is necessary. And if the customer wants to evade CloudFront, because CloudFront, okay, up to 1 TB of egress traffic is free, but when you when you exceed the threshold of 1 TB, the cost can be much. So if the client won't need CloudFront, we can eliminate that.
Hello, did we lose James?
And
I think we lost James for a minute, if I'm not wrong. Yeah?
Sorry. I don't know what happened to my network connections. Can you hear me?
Yes, we can hear you.
Nice. Kevin, did I answer your question, or maybe I left while I had not concluded? Or maybe Mark, did you hear my response, or I was breaking?
Yes, I think we had most of it. If possible, what you can do due to time, we can cut it short there. Just one last question. I don't know if hopefully it can added on. Where can people learn more about, let's say, the 3-tier architecture and being a solutions architect, and also also talk about RCA Cloud and what you guys are, the good job you guys are doing on that side. I'm seeing ZP here and a few other people as you conclude. Thank you.
Awesome. Thank you, Mark. First, I'd like to say thank you to the audience for, for listening to me. And second, I would like to encourage each one of you, those who would like to have a path of being a solutions architect. It's something that you will definitely enjoy doing. And maybe just one thing that you need to keep in mind is have that roadmap of doing certification, have that roadmap of coming up with projects that are based on designing and all that, and also majorly work on your social skills, because remember this role, it involves interacting with customers. So work on your social skills, and it's a great place to be. Then okay, kindly introduce yourself, James. Okay, I see someone wants me to introduce myself, and okay, James Juma Sindani. I'm a solutions architect at Silicon Overdrive. And apart from that, I'm also a co-founder of a program called Resource Cloud Academy. And in Resource Cloud Academy, what we do is it's a community made up of young tech enthusiasts who will wish to start their career or maybe advance their career in cloud. And what we do is we engage the community in projects. We get mentors who are already in this industry to come and talk to the community and maybe give them advice and roadmap that they can follow to be, let's say, for example, a cloud engineer, let's say a solutions architect, let's say a developer and all that. So it's just a community that is made up of people sharing a common interest who will wish to upskill and advance further in cloud. Yeah, so that's RCA, and I do have Samson Barasa, ZP, Albert, and Awad in the session, who are also the co-founders of Resource Cloud Academy. Then finally, I'm a student at JQuat. I'm taking a course of telecommunication and information engineering, and I'm in my final year. Yeah, so that's me, and thank you so much. Back to you, Mark.
Yeah, thank you very much, James. Maybe you can mention when you guys meet, RCA, and also like where can they find you on LinkedIn, Instagram, whichever place to them.
Nice. Yeah, we do have our weekly meetings on Thursday, and on Thursday, what we do is we do invite guests and mentors, such as what you're doing right now. We get people to share their journey with the community, or two, if they have maybe a presentation in form of maybe hands-on, they have that Thursday. We 10 p.m. East African time. Then we rolled out a new program for the project-based development, where we meet on Sundays. This is a paid session. We interact with the community in terms of projects. So what we are currently doing, going to architect this project, and after architecting it, you're going to implement it on action. So that's a program that we've enrolled. It's a new one, but if you
Great, great. I think we've lost him.
maybe we'll have
Great. Thank you, James. I think there's a bit of a lag there. So as we close off for today, I'd like to thank our co-organizers. Tony is here, Adeline is here. I think Samuel also here, and all other people who really made it happen. Shout out to RCA Cloud. They're really doing a really amazing job. I love to see what you guys are doing, and hopefully that Jikaza, I'll be able to come for some of the sessions that you're doing. Also, I'd like to thank the people who've come through today. We've had more than 50 people here. It's been really amazing. As we finish off, just a few housekeeping things. There is Cloud App that I think I posted on Student Hub. I'm forgetting the name, Cloud Student, something like that, on the chat, which will be out there. If you're a student within university, please be on the watch out for that when they launch in Kenya. Be part of it and really just spread the gospel of cloud. There are a lot of opportunities there. Expand your knowledge. Other than that, anyone who's been accepted in the Community Builder program, congratulations, if possible. I don't know if there are any who've been accepted for this quarter. I think they came out yesterday, if I'm not wrong. If you have congratulations on that, do reach out. We'd like to, congratulate you and also see what you can actually offer the community as we go on. Lastly, I have a request, if possible. You can switch on your videos. We take one screenshot selfie or something like that, just to post and tell people this is what we've been doing. And hopefully as we go on, we'll get to a physical meeting and do more stuff as we go on. Hopefully mmesikia hizo vitu zote nimesema. So if possible, you can switch on your, what are they called? Your videos, and you can take like one picture as you call it a day.
Sorry, Mark, let me just paste that link of the Source Cloud Academy in group. There we go. And yes, we can, you can show our face so that you can then take the picture. But from my side, I'd like to say thank you so much for allowing me the opportunity to share what I had with the community. And I'm looking forward to grow and interact from you guys as we push the gospel of cloud. Thank you so much, guys.
Yeah, great. Yeah, people, if possible, you can switch on your videos. That would be great. I've seen someone who was invisible. Did I see Delphi? Is it Delphi? He was invisible for a minute there. At Delphi, was invisible or something like that. Nice to see you, Duncan. Hi, Lois, Marieleo. Kevin, I think he did a good job on the presentation, on the hackathon. I can see Paul there, Tony. Great, Ruben. So let me start taking as you continue. Kaunaosha uso ndo tuchukue, well and good. You can do it. Haina shida. Great. Sharon Nyambati, hello. Hey, Samson, Oko, Mali, I don't know. Great. Okay. This is a good start as I take pictures. Yes. Okay, we can do one fun one, where I don't know what we should do. Like just put your hands up or something like that. Okay, yeah, like wave or something. That would be fun. Engineers they're too serious for life. Sawa basi, if possible, just wave, say hello, punga hewa. We saw Samson being called at Kona kwa TV. Bill is there. Hello. Hopefully some of you also taken pictures. So thank you very much for coming through. Let me just share my screen again. It's just amazing to see this community, how we're growing over time. Yes, join us on Meetup, follow us on LinkedIn, follow us on Twitter. We're trying to do as amazing things as possible. Also, our trade group are doing a really amazing program. Also, if possible, please join them and see what they're doing. Last but not least, thank you very much for coming through. You guys have been patient. Juma has done a really in-depth job. Loved the details on it. Loved the questions that were there. I think Kevin was asking questions. ZP was there answering questions, which is really cool. I've seen just really good interactions all around, and I think we've been way past time by 20 minutes or so. Probably you've not eaten and you've actually been here. Asante sana. If possible, what you can do, if you want people to maybe follow you on Twitter or LinkedIn, you can also post it here so that you can also kind of really, interact more and more as we go on. Yeah. Other than that, sina maneno, sina maoni, and stuff like that. So you can drop off at your own pleasure as we kind of just finish off today.
Thank you, Mark. Bye-bye.
Pleasure, guys.